Good evening, I'm David Anderson. This evening I will be presenting my final report, which is Why Are We Wasting Our Wastewater Resources, which of course is the final project presentation for Geography 641. For an introduction, I'll be going through the statement of the problem, looking at the intended audience, showing everyone the study area, going into the background with the historic information and then the demographic and environmental information for Colorado Springs and El Paso County, Colorado. I'll touch on the necessary data for the analysis presented in this paper, the workflow that went through it, and then finally I'll go into the results and show some analytical maps and discuss some of my findings in the conclusion. For the statement of the problem, the aim of this research is to analyze methods of returning wastewater to the aquifer through cost-effective means, rather than offloading it and the possible pollutants to surface waters, while ensuring that the wastewater returned to the surface waters is done so in a manner which benefits the environment and the surrounding community at as low a cost to the environment as possible. As one would imagine, the intended audience for this presentation is the Colorado Springs City Council and also the Department of Public Works. You'll notice, of course, that the study area is El Paso County in the larger Colorado Springs area. What I've done here is showed the incorporated cities in El Paso County and also all of the buildup that is around Colorado Springs, as well as the military installations which are near Colorado Springs. All of these features will play prominently into the analysis as we go through and show what's in the area and where the runoff sources are and what can be done. So for a brief background on Colorado Springs, it was originally founded in 1859, and it was supposed to be a supply town for the gold rush that was up in Denver. As everything moved in, of course, it was doing a fairly good job of being the supply town, and the Civil War broke out. After the Civil War, it mainly restarted, but this time as a resort town. However, when gold was discovered in Cripple Creek, Colorado Springs quickly became a boom town and soon was known as the City of Millionaires due to the number of people who had struck it rich up in the Cripple Creek gold mining area. It remained largely a mining and a ranching town up through the approached World War II, and as World War II approached, the United States government began building military installations in the Colorado Springs area. First was Fort Carson, and the military presence grew throughout the Cold War. The second image that I have on here is the United States Air Force Academy. That was shortly after World War II. The Peterson Air Force Base was also put in. One of the great things about it early on for the Air Force Academy and Peterson Air Force Base is the climate is great for flying in the area and for flight training. So the Air Force Academy was able to train the Air Force cadets on flight operations at the Academy fairly regularly, and in fact they still do based on the weather. The picture on the right is part of the United States Space Force complex that is there in the Colorado Springs area, with this one being Shriver Space Force Base. But there is also NORAD Northcom at Cheyenne Mountain. There's the headquarters for United States Space Force and a host of space activities that are in the Colorado Springs area as well. Getting into the demographics and more background, on the left, you of course have the population pyramid chart. And what we see here is that it's a relatively stable community with a large but important cohort of transient residents. As can be expected with a location with high levels of military activities, you will see that there's a bulge in the population of 15 to 34-year-olds, which is decidedly skewed to be more male than female, which would be indicative and in keeping with a military population, especially the breakout in the 15 to 19-year-old demographic, where you have a huge bulge starting out. And that would be interesting to break that out to see how many of those are the 18 and 19-year-old group, who would be the young airmen at Peterson Space Force Base, the young privates at Fort Carson, and of course also the cadets at the United States Air Force Academy. The median age in Colorado Springs is 35, and that's 2 years lower than the median age for Colorado as a whole. And once again, that could be attributed to the lower age cohort of most of the military members. The next thing that we'll notice in the area, 42.5% have a bachelor's degree or higher. And the median income is $82,389 a year for just anyone in the area, and the median income for married couple families is $112,895 per year. Getting into the environmental information, El Paso County itself covers 2,158 square miles, with 21 square miles of that being buildings and roads. Unfortunately, I wasn't able to add the amount of that would be parking lots, driveways, and other non-permeable surfaces. The highest point is 14,115 feet at Pikes Peak, and the lowest point is out in the eastern plains, and that's going to be 5,100 feet. The average precipitation in Colorado Springs is 15 inches of rain per year and 35 inches of snow, which according to NOAA would roughly equate to approximately another 3 inches of precipitation, giving it the equivalent of approximately 18 inches of rain per year. The climate itself in Colorado Springs is going to be a semi-arid climate, with the biomes ranging from shortgrass prairie in the east all the way up to the high alpine tundra at the top of Pikes Peak. Most of the water that is in the Colorado Springs area is sourced from the underlying aquifer. And one of the big things that you would expect, with of course most of the paved and impervious surfaces being inside the city itself, there is a large amount of non-point runoff that accounts for a great percentage of the pollutants which entered into the surface streams. Next, we have the methodology for the study. This was a relatively involved study, and I needed a large amount of data for that. The first, of course, was getting the data for the structures, the roads, the railroads, and the supporting infrastructure. Then, of course, the digital elevation data, the precipitation data, the land use data, soil data, and other geologic data. You'll notice that there is a block to the right which encompasses my 29-stage workflow. Instead of going through each of these items in great detail, I'll provide more of an overview of what's going on in the workflow. First, of course, is building the hydrologically correct digital elevation models. Once the hydrologically correct digital elevation models are built, then you can start building your basins, you can start building your water flows, and you can start building the catchment areas. Once you've built these catchment areas and your water flows, it's now possible to start doing more of the analysis and getting into the impervious areas. So that was where I went in, got the analysis for the structures, got the analysis for the roads and the railroads, and mainly the impervious structures outside of the driveways and parking lots and things of that nature. I went out to NOAA to collect the precipitation data and the environmental data. I went to the I went out to the Geologic Society's web pages to see what they had. I also went to the U.S. Geological Survey, and from there I was able to get the underlying geologic information and the soil information and all of the things that I needed to be able to look at percolation rates, the recharge rates through the aquifer, and start looking at those areas where it would be viable to do settling ponds and also injection wells. Once that was done, I needed to do the topographic wetness indicators, or index rather. The topographic wetness index lets you know where the water accumulates in the soils, and that is an important thing when you're looking at topsoils for the high level recharge rates, and then it gets more into the underlying rock formations when you look at the amount of water that's going to soak back in from settling ponds, or of course where it would be beneficial to put the injection well sites. After that, we needed to do some buffering, so I went through and I started buffering the rasters so I could make sure that we had at least a 50-foot buffer from the houses, 50-foot buffer from the roads, so that way the settling ponds and the injection well sites would not cause instability that would create any hazards of those features being damaged by these reintroduction technologies. And after that, I looked into the actual siting for the wells and the settling ponds themselves. Finally, looking at the results, the first one we have is getting into the impervious surfaces. The next one is after I had done the slopes. The slopes, of course, are going to be very important when you're calculating the topographic wetness index. I went out to the USGS and I got the soils and I got the geology for the area, and I also brought that in as a raster. Once I had those, I was able to put those together and do the buffering. Once I had the buffering done, you'll notice that there is a lot of area right around Colorado Springs where there's really not that much of a good area to do any sort of a injection well or a settling pond, just due to the density that everything is built in. And of course, on the last one, I have one of my analysis slides which show two potential locations where you could put settling ponds in order to start recharging the aquifer in that manner. In conclusion, as the populations grow and demand on the aquifer increases, finding ways not to waste the surface runoff wastewater becomes increasingly important in semi-arid regions of the United States, and in fact all over the world. Based on the analysis for this study, there are nearly 42,000 acre-feet of water that runs off the man-made impervious surfaces each year in El Paso County, with the bulk of that being in Colorado Springs proper. The EPA estimates that the average American family uses 1 acre-foot of water per year, and as low as 1/4 of an acre-foot in the southwestern United States when water restrictions are enforced. And when we start looking at that, 42,000 acre-feet is at least 42,000 families worth of water that would not be pumped out of the aquifer if these aquifer recharge methods were put in place. Last but not least, when we have the settling ponds and the injection wells, according to a lot of the research and the studies that I've looked at in coming up with this study, the settling ponds and the injection wells allow a finishing effect from the water from the surface that the water is penetrating to get down to the aquifer, which removes most of the pollutants and the particulate matter that is inside of the water. So in order to put that back into the aquifer, not only would we recharge our aquifer, we would prevent a lot of the surface pollutants that go in as non-point source pollutions. For the references, this is a subset of the references for the entire paper, but the pertinent references for this particular presentation. And with that, thank you for listening. I appreciate your time. Take care, God bless, and have a great evening.